We are discussing CBSE Standard 12 previous year's question answers for physics. Okay. So now our topics for discussion is electromagnetic induction and alternating current. Okay. So let's resume our discussion. Question number 1. This is 1 mark question. What is quality factor of resonance in LCR circuit? Now, what is resonance? For a particular frequency of alternating current, the resistance offered by L means inductance, C means capacitor, R means resistance. Okay. So suppose we have a inductance, we have a capacitor, and we have a resistance, and this is connected with a alternating voltage source AC. Okay. Now this inductance, capacitor, their resistances called inductive reactance, and this is called capacitive reactance. Okay. What is inductive reactance? Inductive reactance is represented by XL. It is omega into L. What is omega? Omega is frequency of AC, and L is this constant of this. Okay. This in inductance L. This is the constant of this solenoid. Correct. XC is resistance offered by capacitor. This is how much? 1 by omega into C. C is capacitance of the capacitor, omega is the frequency of AC. And what is resistance offered by this? This is I into R. This is ohmic resistance. Okay. Now see, the resistance offered by inductance depends on the frequency of AC. Similarly, the resistance offered by capacitor depends on the frequency of AC. So if frequency is high, then XL will be high. Correct. And if the frequency is high, then XC will be less. So capacitor offers less resistance to high frequency, whereas inductance offers high resistance to high frequency. Correct. So if we adjust the frequency in such a way that this and this cancel out, then only resistance left is this ohmic resistance. This is called, for this particular frequency, the current in the circuit will be maximum. This is called resonance. So at resonance, if we set a frequency of AC, capacitive reactance and inductive reactance mutually cancel each other, and the resistance is less in the circuit, current is maximum. This is called resonance. So now you know that what is LCR circuit, what is resonance. Now what is quality factor? Now quality factor means, suppose if we draw the frequency of AC along x-axis, and if we draw the current in the circuit along y-axis, we find that as the frequency increases, the current increases and it reaches a particular value, and then current decreases. Correct. So this is called frequency versus current graph. Correct. So at this particular frequency, when the frequency of AC is omega 0, say, the current is maximum, peak current is obtained in LCR circuit. So this is called resonance frequency. Omega 0 is called resonant frequency. At this frequency, inductive reactance and capacitive reactance cancel each other and current is maximum. Now, at a frequency, if we increase the frequency above omega 0, then also current decreases. If we decrease the frequency, then also current decreases. Okay. At what frequency the current is 1 by root 2 times the peak current. Okay. So suppose at this frequency, at omega 1, the current is 1 by root 2 times the peak current. If peak current is IP, here it is IP by root 2. Similarly, this occurs twice, at the time of ascending, here also at the time of descending. At this frequency, omega 2, frequency of the AC source, okay, the current is 1 by root 2 times this. Now this width, this is the gap. Higher is the width, higher, flatter will be the curve, and the sharpness will be less, correct? So this width, delta omega, this omega 2 minus omega 1 is denoted by delta omega, correct? And omega 0 is the resonant frequency at which the current is maximum. So omega 0 by twice this delta omega, this is called our quality factor, correct? So this is nothing but at this time when the resonance occurs, then it is omega L by R. So this ratio is called quality factor. So what is the significance of quality factor? Does it have any unit of measure? No, it is frequency by frequency ratio, so it is dimensionless. What it indicates? Smaller is the bandwidth, larger is the quality factor, correct? So if it is very sharp, okay, so smaller is the gap, and this gap is in the denominator, so sharper is this. So what is actually meaning of this quality factor? See, in the radio tuning circuit, when we move a channel, then what happens? We change the radio different FM frequency modulation channel, okay? So when we move the knob, then what happens? The capacitor changes. So in such a way that at a particular frequency, when it is at the resonance frequency, that particular frequency matches, then only that particular radio station plays in our radio, correct? Now if we move a little, or if we move it clockwise that knob or anti-clockwise that knob, different station comes. So sharper is the graph, the noise will be less, correct? So the LCA circuit is giving better performance. But if this LCA circuit is not of that much quality factor, then what happens? If we move the knob, then the current doesn't reduce so rapidly that it can distinguish that current, okay? So if the current falls very rapidly, then what happens? A different radio station comes and play. So there is a 1 hour video for LCA circuit. Just you watch that video. I'll put it again in this YouTube channel. So there it will be very, very clear. So for this 1 mark question, you need to know many things, okay? That is, what is resonance, what is resistance offered by inductance, capacitor, and why it cancel out, okay? And what is this sharpness? Sharpness means this gap is, if gap is more, then the curve will be flatter, less sharp it will be, correct? If the gap is less, okay, this gap is less, then it is more sharp. So first question is answered. Okay, next I'll go to the next question. Obtain the expression for magnetic force acting on a charged particle. This doesn't belong to actually electromagnetic induction, or this doesn't belong to AC. This is previous magnetic effect of current, okay? So what is this? Suppose you have a charge Q, it is kept under it is moving with a velocity, okay? So what is the force experienced in external magnetic field? V cross B, where V is the velocity of the particle, B is the magnetic induction vector of the field. This much force it will experience, okay? So write the expression for this. This is the expression for this, correct? And if velocity and induction vector are perpendicular to each other, if we expand it, Okay, then what will happen? This is VB into sine of angle between velocity and induction vector. If they are orthogonal at 90 degree mutually perpendicular, then this is 0. So this force will be equal to Q into V into B. Correct. What will be the direction of the force? If velocity and the magnetic induction vector, these two are right angle, and any force, and suppose by cross means this direction of magnetic field is perpendicular to this plane of this paper away from the observer, correct? Or it can be like this, perpendicular to the plane of the paper but towards the observer. So this cross indicates, equispaced cross indicates uniform magnetic field perpendicular to the plane of the paper, and this charged particle is entering in this like this, at the velocity is perpendicular to this. Now when, and the force acts perpendicular to it, correct? F is V cross B. So automatically it is perpendicular to velocity, perpendicular to the magnetic field. So such force which is perpendicular to velocity, it moves in a circular path. This force provides the centripetal force. Okay. Now here in the second part of the question it is given a neutron is entering the field. So I already told that force will be experienced by charged particle. Neutron is electrically neutral. So if it is electrically neutral, then it will not experience a force. So neutron will have no force experience. Now alpha particles is double ionized helium atoms. It is positively charged. So it consists of charge of 2 protons. And electron is negatively charged. So automatically if the alpha particle and this electron, they will move clockwise or anti-clockwise, depends on this direction of force that they experience. But certainly if one experience clockwise movement, other way will move in a anti-clockwise direction. So first part is answered. Okay. Now this is, say here, the centripetal force is mv square by r. R is the radius of this circular path, is provided by B V into Q. Correct? This is the force experienced, earlier explained. Now what is the radius of this? So one of the velocity cancel out. So radius is equal to mv. Okay. Radius is equal to mv by bq. Correct? So okay. So m is the mass of the charged particle. Q is the charge on this particle. If it moves with a constant velocity and if the external field is constant, let us keep this to constant velocity of this particle and magnetic field. So R is proportional to mass per charge. Correct? So in this question given whether alpha particle move in a greater circle, radius of alpha particle will be more or radius of electron will be more. Let us see. So mass per charge ratio is higher for alpha particle because alpha particle has higher mass. Okay, whereas electron is lesser in mass. So m by q is higher for alpha particle. So the radius of the alpha particle in which alpha particle will rotate will be more than the radius of the electron. So see here alpha particle moves in the clockwise direction and electron moves in the anti-clockwise direction, and radius depends on mass per charge ratio. Correct? And neutron will not experience any force. Now question number 3. Define mutual, this would be induction. What is mutual induction? We have actually explained in later part what is mutual inductance. Okay, I will come to this. So what is mutual induction? Okay, let us understand first what is mutual induction. Suppose we have a AC source. Okay, it is connected with a coil. This coil where the source is connected, alternating voltage source is connected, is called primary. Okay. Now, when a varying current flows through a coil, then what will happen? Along the axis it creates a varying magnetic field. So this magnetic field is represented by magnetic lines of force. These magnetic lines of force will cut the plane of the other coil which is kept just in front of it, correct? This is called secondary coil. This is primary where source is connected. This is secondary where we need the output, that is load is connected, correct? So when varying magnetic lines of force cut the plane of the second coil, then EMF is induced. Voltage is developed across this coil, across the terminal of the secondary. This phenomena is called mutual induction. So mutual induction means because of the primary flux, secondary experience a EMF and a current flows in the secondary circuit. Okay. Now, to communicate the magnetic flux from primary to secondary, if the very high voltage, then we can keep air. This is called air core transformer. If we don't want the magnetic flux leakage, then we can keep laminated iron path, so that it gives the permeability, means degree of allowance to the magnetic lines of force is more in iron. So iron can carry more lines, magnetic lines, and gives a easy path to cut it. Okay, but there is a overhead also keeping iron. So anyway, we can communicate the primary flux to secondary by keeping a proper medium of ferromagnetic material, or you can keep air depending on what type of how much is the voltage. Okay, so mutual induction means pair of adjacent coils has mutual induction. This is the second part of this question, that the coil has a mutual inductance 1.5 Henry. Henry is the coefficient of mutual inductance unit. Okay, if the current of one coil changes from 0 to 20 ampere in 0.5 second. Okay, so what is rate of change of current, that we will calculate. What is the change in flux linkage with the other coil? Okay, so first of all we will define what is mutual induction. The changes in current in one coil induces EMF in the other coil. This is called mutual induction. Self-induction and mutual induction is different. Self-induction means what? Suppose if we pass alternating source of voltage here, because of this varying lines, because of this varying nature of this voltage, AC voltage, okay, in the one turn it creates magnetic field and cuts the second turn, so back EMF is produced, correct? So effective EMF of the circuit becomes less. So this is called self-induction, and mutual induction means we have two different coils, correct? So this is clear now. And for the second part of the question, we have to calculate what is the flux leakage. So let's say M is the coefficient of mutual induction, which is 1.5 given, 1.5 Henry, and change in current is 0 to 20 ampere. So 20 minus 0, what is rate? Rate of change by divided by time. In how many seconds this has happened? 0.5 second. Okay. So the change in current with time, di by dt, rate of change of current, correct, is equal to how much? 200 by 5. It is 40, correct? 40 is the di by dt. And we know that induced EMF is equal to how much? Minus m di by dt. Why minus sign came? That when we will explain Lenge's law, we will explain about this minus sign. So it is 1.5 given and 40 is di by dt is minus 60 volt, correct? So what is the flux? Flux is equal to this EMF developed into d phi by dt, Faraday's law, okay, is equal to induced EMF. So d phi is equal to how much? D phi is equal to e dt, correct? What is d phi by dt? Rate of change of flux with time. Is it the induced EMF? This is what is the Faraday's law. of electromagnetic induction. So d phi is equal to E dt. E is over 60. 60 into 0.5 is 30 Weber. Weber is the unit of flux. Okay, now we'll come to an AC source of voltage V0 sin omega t is connected to a series combination of LCR circuit. See why I am giving more stress on LCR, because entire physics is about of these two chapters is about this inductance, capacitor and resistance. So you should be very clear about what is the resistance offered, what is the phase difference between the voltage developed across inductance and capacitor and resistance. So then only you can solve such problem. Correct understanding is necessary. So use the phase diagram to obtain the expression for impedance. What is impedance? Impedance is the resistance offered, okay, of the circuit. Total resistance offered is called impedance, and phase angle between them, okay. Because here in DC circuit, current and voltage both goes side by side, okay. There is no difference in phase between current and voltage, but in AC circuit, current and voltage is they are in different phase, okay. That is why in DC circuit we have power is equal to I into V, but in AC circuit power is equal to I into V into cos of angle between them, okay. This is called power factor, okay. So we will come to this. What is phi? Phi is the phase angle between the current and voltage. So find the condition when the current will be in phase with the voltage, okay. That is the resonance condition we have to find out, okay. And what is the circuit condition called? That is the resonance circuit, okay. Let us understand this part, because we need to understand many things for this LCR circuit, okay. So I will draw the circuit first, LCR circuit. This is L, this is our capacitor, and this is our resistance. Sometimes the metallic resistance offered is ohmic resistance of this inductance is shown separately as ohmic resistance, okay, or it is really a resistance connected, okay. So this is AC. Now suppose E is equal to EP, means peak value of EMF sin omega t is equal, this is the alternating voltage applied here, correct. So what is the resistance offered by inductance? It is omega into L, correct. This is called inductive reactance. What is the resistance offered by capacitor? This is 1 by omega into C. C is the capacitance of the capacitor, omega is the frequency of AC. What is resistance offered by the resistance? It is R, correct. Now this current leads the EMF by 90 degree in capacitor. In capacitor, current leads by 90 degree to EMF, and in inductance, current lags. The lags or lead means what? The phase angle between the current and the voltage developed EMF is 90 degree, but 90 degree in both the cases. Capacitor, the phase angle is 90 degree, and in inductance also 90 degree. So remember, how to remember this, which lead, which lags. So just to remember this, you see capacitor start with C. So here current, and current starts with capacitor, this is capacitor C, and current start with C. Just to remember, I am giving you this clue. So in capacitor, current leads EMF by 90 degree. Automatically in inductance, if you remember this, then automatically current lags EMF in capacitor by 90 degree. Okay, so and across the ohmic resistance, current and voltage, they are in phase. There is no phase difference between current and voltage when it passes through a resistance. Okay, now suppose this is my x-axis. Okay, now if I plot it, so when I say current leads EMF, it means that the voltage lags EMF, correct? So I can represent what is the phase difference between this current into the XC, correct? So this is, suppose this is the potential drop across VC, potential drop across the capacitor, okay, I into XC, okay, and what is potential drop across the inductance? Here what will happen? The voltage will, current lags means voltage lead by 90 degree. So here suppose this is the voltage VL, that is the potential difference across the, VL is potential difference across the inductance, VC is potential difference across the capacitor, VR is potential drop across the resistance. So VL is equal to I into XL. XL is the resistance offered by inductance, that is I into omega L, correct? And this is, suppose, I into R, this potential difference across the resistance. Now see, if when I have drawn this vector phase diagram, this is y dash axis, this is y axis. Now VC and VL, they are mutually perpendicular. This is 180 degree. So in vector, what happens when two vectors are at 180 degree, then resultant vector can be written as VL minus VC. Depends which one is more. If VC is less, correct, then VL minus VC. This is the potential drop. Suppose this is the potential drop, combined potential drop for capacitor and this. So these two vectors we have resolved as, because they are at 180 degree apart. So this is this along y axis, this potential drop is obtained. Now this is our, now we have to find out the resultant of three vectors. So out of three vectors, two vectors VL minus VC is obtained here. Now we have, this is VR, potential drop across resistance, okay. Now we use law of parallelogram of vector, correct? So complete this parallelogram, correct? This particular vector, that is the diagonal of the parallelogram, represents the resultant. So what is this much? Okay, this is VL minus VC and this is VR, and this makes an angle phi, correct? So what is the resultant? Suppose this is the resultant potential difference, okay. So by law of parallelogram, H square is equal to P square plus B square. Pythagoras theorem also we can apply, correct? So we have the net EMF voltage across the LCR circuit, series LCR circuit, equal to how much? Root over VL minus VC whole square plus R square. So if we put the values of this, I XL, I square everywhere, so I can be taken out, and then this is equal to XL means omega L, okay, minus this is omega C, VC means I already taken out, plus R. Now when the frequency increases, this is when the frequency, this is increasing and this is decreasing, okay, one is increasing, other is decreasing. So somewhere they will meet, okay. So at this frequency, say this is omega 0, omega L means omega 0 into L, that is the resistance offered by the inductance, becomes equal to the reactance, the resistance offered by the capacitor. Actually omega L is equal to 1 by omega C. This particular frequency at omega is equal to omega 0 means when the resonance occurs, when the current in the circuit is maximum. At this frequency current is maximum. Plot the current along y-axis. So omega 0 square is equal to 1 by LC. So omega 0 is equal to 1 by root over LC. So see, these two will cancel out like this. And what is the phase angle? Phase angle is tan phi. Okay, in this triangle tan phi is P by B, perpendicular by base. So it is VL minus VC by VR. So VL is IXL, means I into omega L, correct? And this is omega C, and this is R, correct? So this is the phase angle. Okay, let's see. Okay, so entire, you can see here, entire vector graph is shown here correctly. So you can take the screenshot of it, and this is how it is represented, resultant, and this is phase difference, correct? Okay. So this question is answered properly. Now we'll move to the second question. In a series LR circuit, XL equal to R, power factor of the circuit is P1. When capacitor with capacitance C, such as XL is equal to XC, is put in series, the power factor becomes P2. Okay, calculate the ratio of P1 by P2. So just now we have solved the series, it was LCR, but now it is LR circuit. LR circuit means inductance, and its ohmic resistance is shown separately, R, correct? Yes, is also. Okay, so it is, this is L, this is L, solenoid, okay, inductance, and this is R. So, and what is power factor? The total resistance offered by this circuit is called the impedance. Okay, that is, what is EMF equation of this circuit? The potential drop across the inductance VL plus potential difference across the resistance is equal to total EMF. The EMF equation will be how much? VL plus VR, potential drop across these two, equal to the total EMF applied, correct? What is VL? I into XL, XL is omega L. What is VR? I into R. So I common, correct? So it is omega L plus R. But since in inductance the potential difference leads the current, if this is the direction of current, then the potential drop across resistance will be IR along x-axis, but potential drop across inductance is along y-axis, that is I into omega L, correct? So, and they are at 90 degree. In the last question also I explained that EMF across inductance leads current by 90 degrees. So that is why it is represented along y-axis. Now, if we resolve these two vectors, what will happen? This is the resultant vector. So what is the total potential drop? This is V. V is equal to, so V is equal to IR square, B square plus P square is H square, and this is plus I into omega L square, correct? So it is I square common, R square plus omega L square. Okay, so okay, so this is, and what is cos phi? This is cos, this this is the phase difference between the resultant EMF and current. Then cos phi is how much? Cos phi is cos phi is B by H. B means R, IR by H. H is equal to this much, I into root over R square plus omega L square. I cancel out R by this. This is the power factor. So to solve this question, it is given that the P1 is power factor. Since XL is equal to R, it is given that XL equal to R means the resistance offered by inductance is equal to the ohmic resistance R, correct? XL equal to R, then if XL is equal to R, then R square plus R square, 2R square. So we have in the denominator 2R square, so root 2R, correct? So it is root 2R, R cancel out and 1 by root 2 remains. So cos phi is equal to 1 by root 2. Okay. Now when XL is equal to XC, so this is called the resonance occurred, correct? So then power factor is equal to how much? Okay. So this is, then when XL equal to XC, then what happens? This resonance occurs means omega L and omega C, they are cancelling each other. The resistance offered by inductance and capacitor cancel each other. The only resistance left in the circuit, in LCA circuit, is the resistance itself, correct? So as the resonance occurs, so in the earlier case also we have explained that when this XL is equal to XC, then only resistance is remaining here. So that is why in the denominator, see in the denominator we have represented R square only. So cos phi is equal to R by R is 1, correct? So therefore the power factor P1 by P2 ratio we have to find out. So P1 by P2 is equal to how much? 1 by root 2, correct? Okay. Now this is interesting question. Write the function of a transformer. Okay. Transformer. State the principle working with the help of a diagram. Mention various energy losses in the device. Okay, and there is a numerical given that the primary coil of a step-up transformer. Step-up means where the voltage is increased. Okay. Suppose 20,000 volt. Okay, we have to convert. So at the electric power generation station, we use a step-up transformer, and near my household we need only 220 volt, correct? So there we use step-down transformer. What is a step-down transformer? A transformer which alters the voltage from higher to lower voltage. So remember two types of transformer. Transformer basically what it does, it transforms the voltage. Okay. So when it is step up, what is a step up? Step up means the voltage across the secondary coil is more than the voltage across the primary coil. How it is achieved? By keeping more number of turns in the secondary compared to the primary. This is step up. So what it does? It increases the voltage of the primary to a very high value. Okay, and current is becoming less. In the primary, current is more. Okay, and in the secondary, current will be less, magnitude of current will be less, but voltage will be high. Okay, so why you use a step-up transformer? Another, I want to answer many questions related to transformer because this needs a very conceptual thing. Why we need such a step-up transformer? See, when a in the transmission line, over a long distance transmission, when we want to send the electric energy through the transmission line, then there is a overhead. What is overhead? It can generate when a very high current. So we need very high current in our household because we need to operate fridge, we need to operate heater, air fryer, AC, okay, electric bulbs, then we have a fan, correct? So many electric appliances are there at our household. So we need more current. So for getting more current to be delivered from the electric power generation, but if more current flows through the transmission line, then what will happen? Heat will be produced. I square RT is the formula for heat. Okay, so heat produced is proportional to the square of current. So that is why we never pass very huge current through the transmission line. We reduce the current, we reduce the magnitude of current. What we increase? We increase the voltage. Voltage is increased. So near my household, okay, we use a step down transformer. There we increase the current so that only high current flows from your nearby power station to your home, correct? So there we use, there at the electric power station we use a step up transformer, and near your household where your house is there we use a step down transformer. What a step down transformer does? A step down transformer converts high voltage to low voltage and high current and low current to high current. So when I say that the secondary voltage is more than primary voltage, at the same time the secondary current will be less than the primary current. Okay, in case of step up. In case of step down, the secondary voltage will be less than the primary voltage. Now we need 220 volt only, but in the transmission line there is 20,000 volt which we supply, but in the secondary current will be more than the primary, okay, because we need more current to operate very many electric appliances. Now let us see. And what is the losses in transformer? See, if a very high current, very high voltage transmission occurs now, then what we do? We use air core transformer. Primary and secondary there is air. There is air. Nothing, air is there. Why? Because in air there is no transmission, flux leakage is there, but transmission leakage, heating effect, eddy current loss, hysteresis loss, all these things are reduced. Okay, but there is a overhead, the flux leakage will be there. Okay, so when to use air core transformer, when to use laminated iron core transformer, it depends on what type of frequency you are transmitting. Okay, if we need flux leakage to be reduced, then ferromagnetic material like laminated iron to be used. So instead of solid iron, thick iron bar, we use plates of irons, okay, one after another. Okay, so that is called, this is how we can reduce to some extent. Okay, but there is a loss. So we have to discuss about the losses of transformer. And then it is given that the primary coil in a step-up transformer has 100 turns. Transformation ratio is also 100. Okay, so normally this is a very ideal situation that input power and output power is same. Normally no transformer operates at such efficiency. Okay, there is a loss occurred. So the input voltage and power is represented by 220 volt to okay, power is 1100 watt. Calculate number of turn in the secondary. So you will learn many things here while solving this question. Okay, let's proceed. So transformer is based on the principle of mutual induction. So when primary alternating voltage applied, so then this produce magnetic field. So the magnetic lines of force passes through this core. High permeability material, like what is permeability? The degree of allowance given to the passage of magnetic lines of force is called permeability. So if it is a ferromagnetic material, this magnetic lines of force will come and it will cut the plane of the secondary coil. You know, this will be varying in nature because it is AC. So the principle of mutual induction, electromagnetic induction, is this: lines of force must cut the plane of the coil and it should vary with time. So both the condition is satisfied, so therefore the mutual induction will happen and we will get a load voltage across the load, correct? So this is step down transformer. You can take the theory part of it. Okay, see, there is a number of turn in the primary and number of turn in the secondary. There is a difference, okay, depending on whether you step up or step down. So okay, now if phi is the flux of each turn, so across secondary is equal to number of turn in the secondary into d phi by dt. This is Faraday's laws of electromagnetic induction. What is Faraday's law? The EMF induced is proportional to the number of turn and EMF induced is proportional to the rate of change of flux, correct? If we combine both these things, so E is equal to, there is a minus sign because it is opposing EMF, N d phi by dt, and this negative sign we will explain when we will discuss about the Lenge's law, correct? So this is similarly in the primary, it is Np d phi by dt, rate of change of flux in the primary. So but Ep is equal to Vp, means it is given, since the primary coil has zero resistance, and Es is equal to Vs. If the current taken in the secondary coil is small, then Vs is the voltage across the secondary coil. Okay, so now if we divide these two, so Vs by Vp means voltage across secondary by voltage across primary is simply the ratio of number of turns, correct? So Ip Vp is equal to Is Vs. I is current in the Ip is current in the primary, Is is current in secondary, correct? So this is the ratio. So if we want high current in secondary, okay, then see number of turns are reciprocally related. Voltage and number of turns are directly related. Vs is directly proportional to Ns, but I is inversely proportional to the number of turns, correct? Okay. So energy loss. Now, first of all, what is AD current loss? See, there is localized current. What happens when we pass current through a laminated iron core? A local loops of current is developed. Okay, this localized current actually kills that current. Okay, it absorbs that current. It absorbs that energy. Okay, it reduces that energy to transmit to the secondary. So these localized current are called eddy currents. So alternating magnetic flux induces eddy currents in the iron core. That is why there is a eddy current loss. Copper loss means because of the material, okay, energy loss takes place due to the heating effect of copper, because now when current passes through this laminated core, then automatically heat will be produced. This is called copper loss. Flux leakage. Suppose all the magnetic flux produced in the primary not necessarily will connect to the secondary. Okay, some of the flux will not communicate. So this is called flux leakage. Okay, to reduce the flux leakage, we can use laminated iron core instead of air core transformer. Correct, but there is overhead. Then you have to suffer eddy current loss. You have to suffer hysteresis loss. What is hysteresis? See, the process of magnetization and demagnetization involves some retentivity in that core, correct? So AC flowing through the iron core takes through the cycle of magnetization. You know this is hysteresis curve. I will explain later whenever I will have this topic. So this is hysteresis loss. Magnetization, demagnetization. Okay, so the area indicates the how much energy will be consumed because of this hysteresis loss. So the process of magnetization happens and demagnetization happens. Okay, reverse process happens. So this work done in each of these cycles causes energy loss. This is the hysteresis loss. Correct? So in briefly, I have explained what is transformer, what is its principle, what are the losses, what is step up, what is step down, and what is the relationship of primary and secondary coil. I think this will help you to solve any type of question related to transformer. Now in the question given, number of turn in the primary, number of turn in the secondary, and efficiency is output by input. The eta, it is represented by eta. Eta is here given as 100. So eta is equal to output voltage by input voltage, and output by input is equal to what? Ns by Np. Okay, it is given. We have already explained. Vs by Vp means the voltage across secondary to voltage across primary is Ns by Np. So eta is given 100. So we can find out what is Ns, number of turn in the secondary, which is 10,000. See, number of turn in the primary is 100. In order to increase it a higher voltage, okay, you need 10,000 number of turns in the secondary. Okay. So now second part is this: the primary across voltage is 220 volt and power is 1100 watt. Current in the primary is how much? So current is this IPVP, so we can find out the primary current is 5 ampere. Third part of the question is Vs by Vp and Ns by Np. So what is the voltage across the secondary is 22,000 volts. So we are converting 220 volt to 22,000 volts simply by making the turn change from 100 to 10,000. So if you have a secondary of 10,000 turns, your voltage will increase from 220 to 22,000. Okay. Now Vs into Is, that is the potential difference across the load. This is I into V is the power. So Is is the current. So Is is equal to how much? 1100 watt is given power. Okay, and 22,000 is the voltage obtained. So the current across the secondary is equal to 0.5 ampere. This is what I am saying again repeatedly, that the voltage is increased across secondary by 22,000 volt, whereas the current is reduced to 0.05 ampere. So such low current, it passes through this transmission line, it will consume heat, still it will consume heat, but very less heat, correct? So remember, when the current flows through our high tension transmission wire, the here voltage is very high, but current is very low, correct? 0. So while solving this question, you must realize what it is, correct? So P is equal to power Vs into Is. So it is voltage across secondary is 22,000, current is 0.05, so we'll get 1100 watt, correct? Next question. Or we'll resume our next class, because now it will be too much overloaded. So we have to go by one. So we'll explain the next question in next class. Thank you.